All right, welcome to The Explainer. Today, we're going to pull back the curtain on one of the most powerful and kind of invisible forces that's shaping your world, neural networks.
You ever stop and think, how does my phone know it's my face? Or how does my music app seem to know the exact song I want to hear next? Well, it's not magic. The answer is actually a technology inspired by the most complex thing we know of, the human brain.
Okay, so let's dive right in. See, for the longest time, we had to tell computers exactly what to do, step by step with rigid instructions. The revolutionary idea behind neural networks was, what if we could build a machine that could learn and adapt all on its own, just like we do?
So what is a neural network, really? Well, instead of thinking about one single super smart processor, I want you to picture a huge web of tiny, simple nodes all connected and talking to each other. It's a structure modeled on our own brain, and it's designed for one main purpose. Not just to calculate, but to learn.
So how in the world do you go about building an artificial brain? Well, you start with the same basic building block as a real one, a single, simple artificial neuron.
Think of each neuron as a tiny decision maker. It takes in all these different pieces of evidence, right? The input data. Then it decides how important each piece is by giving it a weight. And finally, based on all that combined information, it makes a call. It's a beautifully simple, but really powerful logical process.
But here's the crucial part, and this is where the magic really happens. A single neuron, by itself, is pretty weak. The real power emerges when you connect thousands or even millions of them together into a layered network.
So it all begins at the input layer. When a computer looks at a picture of a cat, it doesn't see a cat. No way. To the computer, it's just a grid of thousands of pixels, basically a bunch of numbers. This raw, unfiltered data is the starting point for everything.
Next, all that pixel data floods into what we call the hidden layers, and this is where the real thinking happens. The first layer isn't looking for a cat, it's just identifying really simple things, primitive shapes like lines, curves, and colors. Then, the next layer combines those simple shapes to recognize more complex features, like an eye, or an ear, or a whisker.
And finally, the output layer takes all those pieces that the hidden layers figured out, the ears, the whiskers, the tail, and it puts it all together to make a final, decisive call. Based on the evidence, it concludes, cat. It's a complex judgment made from incredibly simple building blocks.
But hang on, how does the network get good at this? How does it know which features are important and which aren't? Well, it learns through this fascinating process of trial and error. It's this constant cycle, a two-step dance. First, the network makes a guess, a process we call forward propagation. Then, it gets feedback on how wrong it was. But here's the really clever part. It works backward through the entire network, slightly adjusting every single connection to make a better guess the next time around. This backward correction is called backpropagation, and it's the absolute engine of learning.
And that's really the key takeaway here. A neural network's power isn't just in its structure, it's in its ability to relentlessly learn from its own mistakes. It repeats this cycle of guessing and correcting millions of times, getting just a little bit smarter with every single attempt.
So, I know this all sounds a bit abstract, but this learning process is the engine behind technologies you are using every single day, often without you even realizing it.
And different types of networks are built for different jobs. You have things called convolutional neural networks, or CNNs, which are masters of visual data. They're what allow machines to see. And then you have transformer models, which are the powerhouses behind language, enabling everything from real-time translation to the virtual assistants on our phones.
Seriously, think about it. The Face ID on your phone, the movies Netflix suggests, the fraud alert you get from your bank, this isn't science fiction. This technology is already a quiet, invisible co-pilot in our daily lives.
And the impact is just staggering. In critical fields like medicine, neural networks are now analyzing medical scans to detect diseases with over 90% accuracy. That's a level of performance that now rivals and in some cases even surpasses trained human experts.
This isn't some futuristic fantasy. This is the reality right now. And all of this leads to one final, powerful question. If this is what AI can do today, what challenges are we going to solve with it tomorrow?